impeller is housed within the volute casing, and the impeller is the rotating item that we're looking at now. This is the impeller viewed from the top. We've got a bore in the middle. That allows us to connect the shaft to the impeller, and the angular rotary motion from the shaft can then be transferred to the impeller. The items indicated now are called vanes, and the gaps between the vanes are known as channels. On the back side of the impeller is a base plate, and this plate is what they refer to as a shroud. It's possible for impellers to have 2, 1 or no shrouds. Let's just rotate back around the other side. The type of impeller we're looking at now is called a semi-open impeller because it only has 1 shroud. There are 2 other designs of impeller, and these are referred to as closed or open. We're going to look at these different designs later in the video. Let's have a look at how exactly the impeller works. Well, the impeller's job is to change kinetic energy into pressure energy. So we're exchanging velocity for pressure. We use a prime mover, such as an electric motor, in order to rotate the impeller. The impeller rotates within a fluid, and as it does so, it creates a negative pressure around the impeller eye, which is located at the center of the impeller. This negative pressure draws the fluid into the impeller. Because the impeller is rotating, the fluid is thrown outwards radially due to the centrifugal force that's imparted on it from the impeller. Notice that each of the vanes has a gradually increasing gap between it and its neighbour. For example, we can see here that the gap is quite small, and when we get to the outer periphery, the gap has become quite large. This change in dimension is the reason the impeller can change velocity to pressure. Bernoulli's principle states that if we have a constant flow and a change in area, then the velocity will be correspondingly changed as well. So if we have a steady flow and we have an increase in area, we'll get a corresponding reduction in velocity. If we have a steady flow and a decrease in area, we'll get a corresponding increase in velocity. Notice also that the impeller has a certain number of channels, and the number of channels varies depending upon the fluid being pumped. For fluids with few or no suspended bodies, such as fresh water, the impeller will have between 5 to 10 separate channels. As the number of suspended bodies within the fluid increases, the number of channels will decrease. Varying the number of channels depending upon the flowing medium will ensure the best possible pump performance. As already mentioned, it's possible to have an open impeller. That's one that has no shrouds, such as the one we're looking at now. A semi-open impeller, which has 1 shroud, and a fully closed impeller, which has a shroud both on the top and the bottom. Open impellers are ideally suited for handling fluids with a large amount of suspended solids. However, they are also structurally weak and inefficient. Semi-open or semi-closed impellers have a greater mechanical strength than open impellers due to the shroud where the vanes are mounted. This type of impeller is ideally suited to handle fluids with small amounts of suspended solids. Closed type impellers are the most efficient type of impeller, compared to the semi-open and fully open designs. Closed type impellers employ a front and a back shroud, and this use of shrouds gives the closed impeller a much greater mechanical strength compared to the open and semi-open impeller designs. Although closed impellers can pump slurries or fluids with a large amount of suspended solids, the wear rate on the impeller will be excessively high. The closed type impeller is typically used for fluids with a very low number of suspended solids. Impellers are also classified by suction type. This can be either single or double. A single inlet impeller allows the fluid to enter on only one side of the impeller. The single inlet impeller is the most common type of impeller used for centrifugal pumps. The double inlet impeller allows fluid to enter from both sides of the impeller. It's also possible to classify impellers by the flow type. Radial impellers are those impellers that we've been looking at throughout this video. These are impellers that use centrifugal force to throw the fluid out radially away from the center eye of the impeller. Mixed flow impellers use a combination of radial and axial flow. Axial flow impellers rely almost exclusively upon axial flow, although some of the fluid is thrown out radially due to the centrifugal motion of the impeller, and that is why axial flow impellers are still classified as centrifugal impellers.